Hi, welcome back to a video series on MAT 1033 Intermediate Algebra. This is video number 42 in the series, Factoring Special Polynomials. So I try to encourage a minimum amount of memorization when you're doing mathematics, but there are some polynomials for which it's definitely worth memorizing some special formula, either because it's going to save you a lot of time versus the generic method, or because the pattern itself is useful in its own context. So a real time saver is going to be the perfect square trinomial, although we'll see in the quadratic equation video, it's also pretty useful in its own right. So first consider the square of a sum. As you know, this is not the sum of squares. We need to FOIL, and in FOILing we produce four terms. The two middle terms will actually be like, so we can combine them, and in the end we get a squared plus 2ab plus b squared. What we want to notice about this is that there are squares on each end and twice the product of their square roots in the middle. So what we can use this for is that if we can recognize that there are squares on the end and twice the product of their roots in the middle, then we can save a lot of time factoring. So let's see an example of that. Here I have 100x squared plus 80x plus 16. What we don't really want to do is take 100 times 16 and look through the factors of 1600 for things that sum to be 80. That would work, but it's going to take some serious time. So instead, what we want to notice is that the first and last terms here are both squares. This is 10x squared, and this is 4 squared. If we see that the first and last terms are squares, then we should check to see if that middle term is twice the product of their square roots. That is to say, of 10x and 4. Is it 10x times 4 times 2 in the middle? It is. That's 80x, and that was our middle term. So if we see that, we can just factor by formula by taking my a to be 10x and my b to be 4. That's what this looks like, so it must factor this way. And so we have that 100x squared plus 80x plus 4 is 10x plus 4, the quantity squared. Now, a similar formula holds if the middle term is negative. Actually, this is just as true if b is negative and we're taking a plus b, so we already really have this formula already, but just so that we see it in terms of a negative sign, if I expand this polynomial, I wind up with negative 2ab in the middle, and so we could also look for positive squares on the end and a negative twice their product of their roots in the middle. Now, another pattern, which is very useful in its own right, is the difference of squares. That is to say, a squared minus b squared. Notice that if I FOIL a minus b times a plus b, the middle terms, ab and minus ba, cancel, and we lose our middle term. One context where this pattern shows up in its own right, and we saw this, is multiplying complex numbers by their conjugate. So what we're going to do now is look for squares with a minus sign between them and no middle term. So here, think about what squares would give you these two terms. If we take a to be 11x and b to be 9, then this polynomial has the form a squared minus b squared, which we know factors as a minus b times a plus b, and plugging back in, we get 11x minus 9 times 11x plus 9. This is much faster than the AC method in this case, right? Where we would have to take 121 times 81 and look through its list for factors which sum up to be 0. Okay, critical notes time. I want you to copy this down and show it to me later. Here are some special formula. This is perfect square trinomials. I've put a plus and minus symbol here so I could write both formula at once. That will turn into the same sign between a and b here at only squared. So if this is a squared plus 2ab plus b squared, this is a plus b squared. If this is a squared minus 2ab plus b squared, this is a minus b squared. Now, if I have the difference of squares, that factors as the product of a minus b with a plus b. So now let's take a look at a couple praxis exercises. Give these a shot on your own. Pause the video at this time and see if you can apply the formula we learned to these two equations. Remember, you're looking for squares, their roots, and perhaps twice their product between them. Okay, let's see how you did. So the first one, 4x squared minus 20x plus 25, is indeed a perfect square. The first term is 2x squared, and the last term is 5 squared. So we check to see if the middle term is twice the product of those roots. 2 times 2x times 5 is indeed 20x, and so we factor by formula as 2x minus 5 squared. Then we have 400x squared minus 169. I gave you some big squares in this case, but you should have known by metagaming at least that you could hunt for some squares here. This is indeed 20x squared, gives you 400x, and 13 times 13 is 169. If we factor by formula, this is my a and this is my b. I have a minus b times a plus b, and we're finished. Here are some supplementary notes for this video. The formula that we are looking at here are actually part of a bigger family